All right, we're going to talk about Newton's third law now. Newton's first law told me that an object will not accelerate, its motion will not change unless you apply a force to it. Newton's second law told me how an object accelerates when you apply a force to it. Newton's third law tells us really what forces are. For every action, there is an equal and opposite reaction. Equal and opposite reaction. Now, this isn't talking about action, reaction like you and I think about, let's say, cause and effect every single day. This is very specific. So we're going to need to be precise here when we're talking about that. So, every force requires two agents or objects. Objects is an easier way to say it. So, the way it works, agent 1 applies force to agent 2. This would be the action. The reaction is agent 2 applies force to agent 1. Object 1 pushes on object 2. Object 2 pushes back in that moment. So, let's look at a box. And a man pushing on that box. So, the man applies a force to the box pushes back on the man. Alright, so the man is agent 1 and the box is agent 2. So the man pushing on the box is the action. Man pushes on box, and the reaction is the box pushes back on the man. This is the formula that action and reaction are going to take. So we're going to go through a couple of different examples. What we have to remember, action, reaction, is that these things are equal. Okay? Action and reaction are always equal. So, man pushes on the box pushes back on the man. Now, to determine movement, for the box, it has a force acting on it. There may be other forces acting on the box, but we see only forces on the box matter for the box's movement. Now, the man also has forces acting on him. Okay? He has an equal force to his push from the box pushing backwards on him. Those two are equal and opposite. But he also has some frictional forces acting on him as well. And again, it's only his forces that matter to him. These two do not cancel out, and we're going to write that down. Action and reaction do not cancel because they act on different objects. Oops. Action and reaction do not cancel out because they act on different objects. The man pushes on the box pushes right back on the man, but the box moves because it was pushed. These forces cannot cancel each other out. So we're going to look at one easy example and then one tricky example of the third law. So our easy example involves a big truck. It's a semi. Driving down the road at, let's say, 50 meters per second. It might be dangerously fast, but that doesn't matter. And the truck is driving towards a fly. The truck is driving towards a fly. That's hovering in place. So, when the truck hits the fly, who experiences the greater force? So let's analyze our situation. Let's look at the force of our impact. So, first thing we need to do is look at the two agents in this force of the impact, or the two objects that are involved. So for the first one, we have the truck. For the second one, we have the fly. So our action is the force of the truck on the fly, and the reaction is the force of the fly on the truck. This is a Newton's third law of force pair. So what we're seeing here is equal and opposite forces. So who experiences the greater force? Neither. They have the same force acting on them. So why is it that the fly is smushed all over the windshield of the truck, but the truck is just fine? Well, let's look at it. For the truck, we have a really big mass and a really tiny acceleration. When you hit a fly in your car, the acceleration hardly changes. For the fly, though, you have a really, really tiny mass. And so the fly has a huge acceleration. He goes from 0 to 60 almost instantly. Okay? So the forces can be the same here, but the difference in mass determines who's going to feel that force more. Last example. Let's say we have a box sitting on a table. There are two forces acting on this box. One of them is weight, the force of gravity. The other one is the table pushing up on it. We'll call it N, and we'll talk about that in the free body diagram section. We have the weight pulling down, the table pushing up on the box. So, what is the reaction to the weight of the box? And what is the reaction to the force of the table? These are the two questions that I want to answer. Action and reaction to the weight and to the normal force. So, for the weight, what we're going to do is identify the two objects involved in giving the box weight. Well, one of them has to be the box. Okay. The other one, what's pulling on the box to give it weight, is the earth. Look back at the Newton's second law video, but the earth is the thing that pulls on the box to give it weight. If the box weren't sitting on the table, I'd still have the weight pulling down on it. So the table doesn't go into this at all. The table cannot be the reaction to the weight. So let's look at this. Action is the earth pulls on the box. The reaction is the box pulls on the earth. Now, the little bit of force that's here with the box, doesn't really, well, can change the motion of the box, can accelerate the box. But the earth is huge. And if we think back to the last example, the mass of the earth is so big that the acceleration of the earth is tiny in this interaction. So, our action is the earth pulls on the box. The reaction to the weight then is the box pulling on the earth. So, let's do the same thing for this table force, this what we call a normal force. So, our two objects involved here are a little bit easier. We can see both of them. We have the box and we have the table. So, action, the table pushes up on the box. The reaction is the box pushes down on the table. So the reaction to the table supporting the box is the box pushing down on the table. Now, all of these things are interconnected, but as far as action and reaction go, for specific definitions, this is what we are talking about. And it gets infinitely easier when we look at the two objects involved in the force. And it has to be two objects. It's not the box and gravity. Gravity is not an object. It's not the box and weight. Weight is not an object. It's the box and the earth. Those are the two objects involved. And action-reaction is between those two objects. And with this one, it's the box and the table. And action-reaction is between those two objects. So, that's it for Newton's three laws.